Hello. Okay, so when you have intersection of parabolas and lines is what we're talking about. So three things can happen. You can have a parabola. Oh, thanks. You have a parabola, something, it doesn't have to be concave up, and you have a line and you've got two points. They intersect. Alright? Or we could have a parabola, it doesn't have to be concave down, I'll do concave up. Sorry, concave down rather than concave up. And you could have a one single point and the line is a tangent. It just touches at that point. That's so 1 point. Or we could have a parabola that goes like that, and then you could have a line that just totally misses. So those are three options, 0 points. Now how we know is all to do with solving simultaneously, and then you get a new quadratic equation, which then, coming back to the discriminant, which we've spoken about before, you then look at the discriminant to see if you have 1, 2, or no points of intersection. So let's have a look. How many points do y equals 2x plus 1 and y equals x squared minus 2x plus 3 intersect at? Question mark. Alright, so the first step, I'll write this in blue, is solve simultaneously. Now, well, we've got y is equal to all this, and then y is equal to all this. So where the 2 points, where the two lines cross, it must be that the 2x plus 1 is equal to this thing. And so we write that 2x plus 1 equals x squared minus 2x plus 3. Now I'm going to move everything over to one side. And so we're going to get 0 is equal to x squared minus 4x plus 2. Now, this new quadratic represents the intersection of the two lines, of the curve and lines, right? It's not a kind of parabola on the plane. That's not. It's a new quadratic equation that represents how they're kind of the two things are interacting. And so the discriminant tells us about the lines or the points of intersection. All right? So they tell us about the point of intersection. So what do we have? Well, we've got A, B, and C. A, B, and C. So if we find delta, delta is equal to b squared minus 4ac. Remember, it's the part under the square root, so it's minus 4 all squared, minus 4 times 1 times 2, 16 minus 8, which is equal to 8, which is greater than 0. What's my conclusion? Well, my discriminant is greater than 0. Delta is greater than 0. Therefore, the line and parabola intersect twice. Now, you think, well, nowadays, of course, it's easy to check that. Y equals 2x plus 1. I'll just hop across to our friendly Desmos that allows us to do that. So 2x plus 1 was the first one. And then the second one was, of course, I forget what it was, x squared minus 2x plus 3. X squared minus 2x plus 3. And what do we see? Well, we've got 2 points of intersection. There's one here, 3.414, and there's one here. Now, it's important to note that the discriminant of this blue parabola would be negative. Why is the discriminant of the blue parabola negative? Well, it's because it doesn't intersect the x-axis. It's actually positive definite. But that's not what we're talking about. We solve the two simultaneously, and when we solve the two simultaneously, we get a new quadratic, which shows up there. Well, the discriminant is positive of that new quadratic equation, which means that, hey, our 2 points, we cross twice, and I'm not really interested in finding the point at this stage. Okay, so that's handy. All right, let's try a second example. What is the value of P if y equals x minus 3 is a tangent to y equals x squared plus 2x minus p. Well, let's do plus p. Okay, so this value here is a bit different. It's p. So we're saying for x minus 3 to be a tangent to this parabola, now tangent means 1 point, and it means that delta is going to be equal to 0. That's the thing that I know of new quadratic equation. So we've got to find that. Now, same thing applies. We've got to solve simultaneously. So solve simultaneously. I can't spell, but that's okay. So we have x minus 3 is equal to x squared plus 2x plus p. I'm going to move everything over to one side. X squared plus x plus p plus 3. Now I'm going to put my brackets around this because this is my a, b, and this whole thing is actually my c. So delta, the discriminant of my new quadratic equation there, is equal to 1 squared minus 4 times 1 times p plus 3. That's equal to 1 minus 4p plus 3. And I'll just expand this out. 1 minus 4p minus 12, which is equal to minus 4p minus 11. Now, what did we say was a condition? The question says, what is the value of p if this line is a tangent to y equals x squared plus 2x plus p? So for it to be a tangent, it's one solution. Delta is equal to 0. So we have minus 4p equals minus 4p minus 11 is equal to 0. Minus 4p equals 11. So p is equal to negative, well, it's actually going to be 2 3/4, but it's negative 11 on 4, or we could say 2.75 is what it's going to be. Now again, we can check this. So I'm going to do that. So we've got to sketch these. I'll hide these guys. If I can hide it at all. Oh, it's decided to have enough. Why aren't you moving? Well, Desmos has decided to freeze, so let's put that away. And let's have another look. So x minus 3, x squared plus 2x minus 2.75. Okay, so x minus 3, that's my straight line. And then x squared plus 2x minus 2.75. And you see that there's a tangent there. So our mathematics is correct. It lines up with the graph. But if I change that, say, to 2, it's not a tangent. But if I do 2.75, it is a tangent. So as the value changes, it kind of gives me that point of intersection. Okay, now as a short exercise, exercise 9.5. So give it a go, see how you go with it.